First, I will do recap for 5 to 10 minutes, and then we'll start with today's topic. So, in yesterday, we have seen different subtypes of an attribute view. We have seen what is derived attribute view. Derived attribute views are also known as reference attribute views. What is the use case of a derived attribute view? We cannot use the same attribute view twice in an analytic view. If we have a requirement having the same attribute view with a different name, for example, like AT customer related information, you would like to do analysis based on ship to party. So we can use customer as a base attribute view for ship to party and create an alias attribute view. What is the difference between a derived attribute view and copy? In derived, we cannot do any changes. In copy is like a template. You're taking as a template. In derived, you're referencing to another attribute view. In copy, we take as a template, we do required modifications, and then we activate. So copy is independent, but derived is dependent. It's dependent on the base attribute view. So whatever we make changes to the base attribute view, those changes will also be reflected in the derived attribute view. We have seen what is a design time filter. Design time filters, first of all, are used to improve the performance of a view. Why and how it improves the performance? We don't have to transfer the entire data to the client location, to the client or to the front end, and then do filter. Rather, we can filter data directly at the table level before even the data leaves the table. So what is the advantage? The less the data you transfer, the more faster the data reaches the front end. So based on a business requirement, for example, I would only like to see few company codes, or I would like to see few order types. Then I would filter those, or I would see few bill types, different types of billing. I would like to filter data before even the join is executed. It helps to improve the performance. Design time filters are also known as constraints. Next, we have seen the difference between a text join, how we can use text join. We know the usage of text join. Text join are used to show descriptions based on user session. But similar functionality of a text join can be implemented on a single table by using system variables. At the ending of the session, we have discussed about the column view. What is a column view? A column view is a view. A column view is a view is a runtime view. Whenever we activate an attribute view, a column view is generated in a schema _sys_bic. HANA is model to code. We model, system generates the code. We define relationship between tables, system generates the code. So HANA is based on model to code. So whenever we activate an attribute view, there is a column view that is generated in sys_bic. This is a system schema. In a column view, we have the code that is generated by system. Finally, in the yesterday's session, I concluded with tables are in schema, information views are in content, data processing engines are inside index server. Tables are in schema, schema is in the catalog, views are in package, package in content, data processing engines inside index server is heart of HANA. So whenever we try to process data model, whenever we are processing a data model, processing is nothing but right click and data preview. We see data preview. So whenever business is requesting data from these views, based on the logic that is available in a column view is in sys_bic. It processes the logic in the column view. Based on the conditions, it fetches data from in-memory tables. Tables in memory. Tables are organized in column fashion. Tables are in catalog. It processes data from catalog because view doesn't contain data. It only accesses data in runtime from data that is in memory and organized in column tables. And finally, based on these conditions and based on the data that it gets from in-memory or column tables, everything is processed in the data processing engines. So what is the engine that is involved when we execute an attribute view? When we execute an attribute view, the engine that is involved is a join engine. What is join engine optimized for? What is the use of join engine? And why an attribute view needs to be executed on a join engine? You see, when we deal with master data tables, for master data, we create entity relationship models. Means we need to join tables together. Like, for example, how we join KNA1 with T005T or 5U. So we have tables spread across the database, but we need to join these tables together in a meaningful way by defining entity relationship models. And whenever a model we define is an entity relationship model, means we are basically joining entities to get meaningful information. Like, country is located in one table, country text is located in another table, company code is located in one table, the related company codes and sales organization. So what sales organizations belong to what company code? Or this sales organization or this company code is operating in which currency? So to get a relationship between these entities and to process these relationships between tables, which is the engine that is optimized? When the relationship model is an entity relationship model, you're basically defining relationship between entities. So these data models are optimized to process on join engine. So simply to say, join engine is optimized to process complex joins. Join engine is optimized to process complex joins. So finally, just to conclude the recap, tables in catalog, information views in content, tables are accessed in views, Views have the logic on how to process data from these tables. So based on the logic and based on the data available in these tables, it processes on data processing engines. The data processing engine is nothing but a join engine. Join engine is optimized to process complex joins. So let's go to today's session. In today's session, we're going to start with time-based attribute views. So let me start MS Paint. Now, what is a time-based attribute view? So let me first log into HANA Studio. Let us log into HANA Studio. Click OK. HANA Studio is the UI for HANA. It's the user interface to access HANA database. Let us log into the system. Let us enter the password. Let's go to the package in content. When we right click on an attribute view and click new, subtype, time. Subtype is time. Now what is use of time-based attribute view? Let us take one scenario. Now this is a requirement from business. During the workshop, business is asking the following requirement. He would like to analyze, the business want to analyze data for years. Under each year, what are different quarters? Under each quarter, different months. In each month, different weeks. In each week, different days. In each day, different hours. And then minutes and seconds. So what am I looking at? I'm looking at analyzing my data based on different time-based entities. Let's one example. What is my net revenue in the quarter 1 of 2015? This is the question I'm asking to the data model. What is my net revenue in quarter 1 in the year of 2015? But the way I store data inside a table is something like this. The way I store data inside a table is something like this. For example, it could be any date. It could be any date. A date on which the record was created, a date on which invoice was generated, date on which the billing is generated, date on which the order is created, date on which the delivery is made. It could be any date. Just that we require a date. Just a date is nothing but, it has a day, it has a month, and it has a year. So based on business requirement, this date can change. Whether it is order date, creation date, delivered date, billing date, any date it could be. Now, based on this date, I would like to analyze what is my net revenue. Based on this date, I would like to analyze what is my net revenue. So I want to analyze my net revenue. So when we have an amount related data, net revenue is nothing but amount. It's amount. Net revenue is an amount. So now what I would like to create, I would like to create an attribute view called AT underscore I would like to create an attribute view called AT underscore time. Now what AT underscore time, how this AT underscore time can add value to this date. Now if I try to query on this table, all that I can do is, okay, the order created date, the ordered date. For example, this is the ordered date or bill date, and this is the amount. So based on what I'm trying to analyze data here, based on date. So on this date, for this order, or based on this customer, anything based on this customer, or based on this material, or based on this company code, what is my net revenue? So based on date, based on customer, material, company code, what is my net revenue? Okay. Now what is my requirement over here? The customer, the business is asking, I would like to analyze data based on year, based in each year what are quarters, in each quarter what is month, in each month what is week, in each week what is day. Now what I can do over here, can I do something like this? I can join this date from an attribute view to that of a date in the transaction table. So this is the master data. So year is actually standard. The way the relationship between these entities, between year to quarter, quarter to month, this is standard. And we have another table which is a transaction table. Now why we call this table as a transaction table? Because it has amount related data. Now what is the business asking me? The business is asking me, can you show me a report for the year of 2015 for the quarter one, what is my net revenue? I'm not doing analysis based on day. My requirement is not to analyze based on day. Because in a day, we may have a million orders, for example. But my requirement is not to see based on day or based on customer, or each customer is purchasing what materials. This is not my requirement. My requirement is to analyze based on year. Okay, now I can do these kind of analysis when I have time dimension. When I join a date of an attribute view with that of a date in the transaction table, I can obviously ask a question for this 2015 year, for the quarter one, what is my net revenue? So it means that business can analyze data based on different time dimensions. Especially business is very, very interested to understand data. What is my net revenue this week when compared to the last week? Why for a particular material in this week the selling was very slow? So in order to do this kind of multi-dimensional analysis, time dimension is useful. In order to analyze data based on different time dimensions, we require time dimension. Next, we know what is the usage of time dimension. Now, how to create time dimension? So, the usage is analyzing data based on different time-based entities. Now, how do we create? Actually, if you see time, in time you have different calendar types. There are different calendar types. Local calendar, factory calendar, business calendar. You can maintain your own calendar types. Means for a particular business, they have a specific holidays, or they follow the standard English calendar. Sometimes they follow regional calendars like Arabic calendar. The calendar is different. We have Tamil calendar, Telugu calendar. So different calendars are there. So What I'm trying to point it over here is, in HANA, there are two calendar types. So especially when defining time dimension in HANA, one is a Gregorian calendar and the other one is a fiscal year calendar. One is a Gregorian calendar and the other one is a fiscal year calendar. So for each of these calendar types, the way they store data, the way they store data for each of these calendar types is different. For Gregorian, you have a set of tables that store these calendar types. For fiscal year, there are different set of table which store calendars for fiscal year. For both of them, now we know when we talk about tables, obviously the tables should be under one schema. Especially tables in HANA is in catalog. In catalog, it should be one schema. The name of that schema is underscore sys underscore bi. So yesterday I highlighted one more schema, underscore sys underscore bic. So here we have two different schemas. Schema 1 is sys underscore bi and schema 2 is sys underscore bic. In sys underscore bi, we store time-based tables. In sys underscore bic, yesterday we have seen one example for column view. So sys underscore bic, one example is store column view. Column views are created when you activate an information view. Sys underscore bi stores the time-based tables. What it store? Time tables. Now, what was my requirement here initially? My requirement was to create a time-based attribute view, at underscore time. Now we are only creating a view. This view needs to access time tables from which schema? From sys underscore bic schema. So this is the view in the content and this is the tables under catalog. Now let's say we created a Gregorian calendar. We are using a Gregorian calendar. So we are using a table from sys underscore bic and using in this information view. So now this view has a table and this table has information about Gregorian calendar. Okay. Now when SAP or when we install SAP HANA database, these tables are empty. They only has the container. They don't have data. It contains no data, but only the container or the structure. But how do I populate data into these tables? Now tables are there, schema is there. Schema is a standard schema. Table is a standard table that is provided by SAP. But how do we populate data into this table? For example, mine is a startup company. I started this company around 3 years back. It means that my business operations started only from 3 years back. There are other companies where business is started 100 years back. For example, IBM. IBM is a 100-year-old company. So when you try to analyze data for IBM, especially based on time, we need to have data generated for 100 years. But just mine is a startup company. Mine is a 3-year-old company. So we have a flexibility. So SAP has given flexibility for us to generate time data. So we can generate based on my business requirement, how much time data I require. So you can select from this year to this year, I want to generate time data and put in these tables. And these tables from sys_bic is used in this view. And this view I can join with transaction data tables to ask questions for business. So this is the scenario. So information view in the content area, tables in the catalog area under sys_bic. To populate data into these tables, we have generate time data option because all the customer will not have the same years of doing business. So based on my business requirement, I generate time data. When I generate time data, this is available in these tables. If the data is available in these tables, I can use this data in view, and then I can combine this data to the transaction tables. And business, when asked the questions in a multi-dimensional fashion, they can try to analyze time-based entities to this data. So let us see how we can create this. So for now, I'm only creating time attribute views. We cannot see the entire scenario. The reason we cannot see the entire scenario is we have to join this time dimension with the transaction data. We haven't yet started with transaction data. Until now, our focus is on the master data. So I'll just complete creating this time dimension. But how and when we can use this time dimension, we can see at the later point of time when we create analytic views. So today now, I will only show how to create this, but the real use case of time is when we actually do analysis based on transaction data. So let us start to create this. So I'll go back to HANA Studio. Right click on the package, click new, click attribute view, provide the name AT_time, provide the label. Label is nothing but the description. Subtype is time. View, attribute view, calendar type. How many calendar types we have provided by SAP? Gregorian and fiscal year. So these are different calendar types. Again, in calendar types, you have something called granularity. What is granularity? Granularity is nothing but how detailed you would like to analyze data. Detailness of data. For example, header data. The total net value of this order is $1,000. But where did I spend this $1,000? On which items did I spend? I bought 10 pencils, 10 pens, 10 books. So what am I trying to do? I'm going to go to detailness. So in the same way, in a time, you can go detail. In this year, what quarter? In this quarter, what weeks? In this week, like you can still go to detailness. Okay. Now, why this granularity is necessary? Granularity is necessary because the way the data is stored in these tables, some tables store data in a summary format. Some tables store data in a detailed format. For example, when I say summary, you only have years. When I say detail, you have a relationship between these entities, like year to month, month to week, week to day. So detailness will be more when you analyze data based on day. Detailedness will be less when you try to analyze data based on year. So when you try to analyze based on year, 1 year, but when you try to analyze days in a year, 365 days. So you have more detailedness. In a year you have 365 days. For each day you're trying to analyze data. Okay. Now why this granularity is important? Now we know what is granularity is nothing but how detailed you would like to analyze data. So here we select calendar type. In the calendar type, what is the granularity? I would like to analyze based on date. When I would like to analyze based on date, it means that it is very detailed, like year, month, quarter, all these business entities you'll have here. You have an option called auto create. Now what is this auto create? You have an option to check and uncheck. When you check, based on the combination of what is the calendar type and what is the granularity, automatically system will propose a table. Now where is this table? In sys underscore BI. If I don't check, system won't propose. I need to manually drag and drop the table. So let system propose and click finish. When I click finish, now what table, so usually if you remember, a data foundation is a place where we define a relationship between tables. Now did I add this table or system automatically propose? System automatically propose because we have auto create option check. So this is the table underscore sys underscore bi dot m underscore time underscore dimension. Let us go back to the catalog, expand the catalog. Let us go to the schema underscore sys underscore bi. Expand the schema, expand the schema, expand tables, expand tables. Under these tables, you see, now I'm going to show you what are different timetables. I'm going to show you what are these timetables that are available in sys.bi. What are the timetables I have in sys.bi? So what are timetables over here? Let us see. So you have total 5 tables. M underscore time underscore dimension underscore year. M underscore time underscore dimension underscore week. Dimension underscore month. M underscore time underscore dimension. And M underscore fiscal underscore calendar. There should be some tool I can copy this table. I think it is Snipper. So these are the tables in sys underscore bi. So all these tables are in schema sys underscore bi. Now, so how many tables we have? 5 tables. Now these, okay, so this is not the table. This table is incorrect. This table is not necessary. So we have 5 tables, 1, 2, 3, 4, and 5. So these 4 tables that you see over here, these 4 tables belong to Gregorian calendar. These 4 tables belong to Gregorian, and this table belongs to fiscal year. This table belongs to fiscal year, and all these four tables belong to Gregorian calendar. So we discuss about the granularity. When you take year, this table gets selected. When you take week, this table. When you select month, this table. When you select date, this table. So all these tables belong to granularity, but each of these table will get selected. All these tables belong to, all these tables belong to Gregorian. All these tables belong to Gregorian, but each of these table will get selected when you select the granularity. When you select day, this table. When you select month, this table. When you select week, this table. When you select year, this table. And this table will select when you select fiscal year. So what was my selection previously? When I selected this, when I create this view, my selection was date. That's why m underscore time underscore dimension is generated. So let us try to analyze this table. When you right click on this table, open data preview. So do we have data in this table? Please see the relationship here. You have date underscore SAP, which is SAP date format. So for this date, what is the year? For this year, what is the quarter? And for this quarter, what is the month? What's the week? And what's the week in the year? So like this, you have different business entities and relationship between these entities. So we just discuss by default, these tables are empty. But already the table is generated with data. The developers already generated this data. I'll right click on this table. I'll delete. Delete all rows. Click OK. Click refresh. Table is empty. So we don't have any data. Everything is got deleted. So like this, by default, you can find these tables like this. So when my company started 3 years back, for example. So in the quick view, so usually you don't find this quick view always. Just close this. So it is something like this, but you can find something like this. So to view quick view, click window, click perspective, click reset perspective, click yes. So once you click yes, it actually displays the default view of HANA Studio. How the HANA Studio default look is something like this. So in here, whenever we lose control of the HANA Studio, just you can click window, perspective, reset perspective. It get to the default view. Now we're in the default view. So what is this option here? At the SAP HANA modeler, we have an option called generate time data. When you click on this option, generate time data, when you click on this option, select the system, click next. What is it telling here? Load time data into time attribute view table. So we need to load time data. So where are these attribute view table in sys underscore BIC? So these are the 5 tables. So when I generate time data under the schema, these tables get loaded. But how do I know what table to load inside these 5 tables? Again, okay, here we need to provide from what year. I want to generate from 2013 till 2016 or 2017. 2017, I want to do some business planning. For business planning, I'm actually generating for 2017. I want to generate from year to year, the granularity. Why we need to choose granularity? Because when you choose granularity day, then based on the combination of this from and to, it knows when the calendar type is Gregorian, when the granularity is day, it knows, system knows it has to generate data in time underscore m underscore time underscore dimension. Starting of the week is Sunday, click finish. So once you click finish, at the bottom you see job log. At the job log, generate time data completed successfully. Double click on the log. You can see the log time data generated successfully. Click OK and click refresh. So once you refresh, now here you could see data for 2013, and the maximum rows by default display is 1000 rows. Sorry, it's the minimum rows 1000 by default, and the maximum rows is 5000. Please see, I can limit to 5000, but if I type in 5001, the current input is greater than the maximum limit 5000. So by default, I can view data for 5000 entries. So this is a configurable, you can configure this, but by default it is for 5000 for maximum, but you can configure this. So it is only sample preview. Now the sample preview that I'm seeing over here is only for a developer, but user has no limit to see data. So when this data goes to the front end, there's no limit at all. Only for a developer, for developer testing, we limit to 5000. Okay, so all that we can do here is, first is identifying what is the calendar type. The second is what is the granularity. Based on the granularity and calendar type, we know what table to choose. Once we know what table to choose, now we know how to populate data into the table using generate time data option by specifying what is from, what is to, what is the calendar type, click finish, data is generated inside table. Now, once done, once we completed this, now you go to the time dimension, 80 underscore time, and system also proposes, if you click on semantics, system proposes these columns for output. So usually we define the output columns, but system automatically proposes the output columns. And if you click on hierarchy, you see there is a hierarchy over here. System automatically create a hierarchy. If I select this and click edit, you see system automatically created a hierarchy. It created a level hierarchy. Under year you have quarter, under quarter you have month, under month you have week, under week you have days. It has sorted a direction in ascending. So this is a standard hierarchy that system has created. Click OK. So these are the columns that system has selected. Now, if you see, there are two important columns over here. One is date underscore SAP and date underscore SQL. Date underscore SQL is for non-SAP sources. Date underscore SAP is for SAP sources. So based on this date, this is a key. So this is a key attribute. So this key attribute, I'm going to join with a foreign key. I'm going to join with a, so this is a key attribute in a time-based attribute view. I'm going to join where? I'm going to join to a foreign key in the analytic view. When I create a multi-dimensional view, when we create a multi-dimensional view, this is the primary key, date, I'm going to join with the foreign key date. And then once the join is successful, then I can analyze data based on different time dimensions. Now all that I can do is validate. Click Save and Activate. Right click on AT_time and click Data Preview. You want to select few columns to the output. Right click on here, Add to Labels. Right click on Quarter, Add to Labels, Month, Cal Month, Cal Week. Click on Tables. For example, so this is the output I selected. I'll just select, drag to the bottom. You can create filters. I'll select here, right click, add to labels. Sorry, right click on here, add to filters. So these are simple filters. These are known as simple filter. You have one more icon over here. Toggle advanced filtering UI. When you click on this, right click on here again, or you can just select here, drag and drop. When you drag and drop here, click show list of values. Click on show list of values. You can select 2013. Click OK. So in 2013, just I'm trying to display few records. Year, quarter, under quarter, these are the months. So if I go to quarter, drag and drop the quarter. Drag and drop the quarter from available objects. First quarter. So for first quarter, and for first quarter, drag and drop the month. Drag and drop the week and each month. Month, drag and drop. First month. So like this. So by this relationship, so this relationship time is automatically generated. So based on this relationship, I can analyze my. So when I join date underscore SAP with date and with foreign date, then I can do multi-dimensional analysis on data. So we've only seen the time, but the whole scenario will be complete when you actually create an analytic view. In the analytic view, we use all these attribute views as its dimensions. Okay, just to again just conclude on this, time-based attribute views are used for multi-dimensional analysis on different time-based entities. The standard calendar types provided is Gregorian fiscal year. The timetables are stored in sys_bi. There are 5 tables, 4 for Gregorian, 1 for fiscal year. Based on the granularity and the calendar type, the tables get selected. We populate data into these tables by using generate time data option, where you can select from to what is the granularity. The data gets populated into these tables. Let us go to the next exercise. In the next exercise, we will see what is the usage of different joins. If you double click on an attribute view, if you select the data foundation, if you select a join, here you see join type. How many different types of joins we have in SAP HANA? For master data, referential join, inner join, left outer join, right outer join, text join. So 5 types of joins: referential, inner, left outer, right outer, text join. Now we know Now we know what is the usage of text join. Now let us go to the next join. What is the usage of inner join? Let us try to understand what is inner join and how inner join will be useful in the business example. Let us take one business example. Based on the business example, let us see the usage of the inner join. Excuse me. Topic here is inner join. Now what is the use of inner join? Okay, now what is inner join? Inner join, now what is a join? Join is a query. Join is a query based on a condition. Now what is a condition over here? What is the condition? The condition is getting common values between different, getting common values between business entities. I'll take one business example, getting common values between business entities. Let us see one example. Now we know the standard SAP enterprise structure. If you see the standard enterprise structure of an SAP, now usually if you see on the top it is operating concern. Operating concern is nothing but the enterprise structure. Under enterprise structure we have controlling areas. Under each controlling area you have different company codes. I'm just taking one example over here which will be relevant for us. Under each company code you have different sales organizations. Under each sales organization you have different distribution channels. So this is the standard enterprise structure that SAP provides. So controlling area, operating concern to controlling area to company codes. Each company code can have several sales organizations. In each sales organization you have different distribution channels. Now this is my business requirement. Now we remember initially when we started to take a functional spec, we designed a functional spec. So what was that functional spec? The functional spec that we have taken was we would like to see customers. This was in third class. In the third class, so customers purchasing what materials, and these are from, you want to do analysis based on company code. So we are actually trying to build this now. We're in the process of building this company code, attribute view. Along with that, I would like to explain the inner join concept. So I'm building a company code attribute view. Along with this, I'm trying to show you how I can use inner join for the company code concept. So here we have company code, sales organization. So what is my initial requirement? My initial requirement was something like this. What is my company code ID? In each company code, what is the name of the company code? In each company code, what is the sales organization? Name of the sales organization, and what currency the company code operates. What currency does the company code operates? So this is my requirement. So company code name, the sales organization name, and the currency at which the company code is operating. Now, what is the relationship between company code and sales organization? What is the relationship over here? Now, for example, the company code is 1000. 1000 means Germany. Germany is the company code. Under Germany, you may have several sales organizations like Frankfurt, Berlin. So one company code can have multiple sales organizations. So one is to many. So one company code can have multiple sales organizations. Now, coming to this requirement, first of all, again, the same procedure I need to repeat. What is the procedure I need to repeat? Prepare a technical spec. Prepare a technical spec. Now, we already know how to prepare. When preparing a technical spec, we know we have been assigned this attribute view for us to build. They assign this attribute view for us to build. So we get from a common repository, from a documentation, our name is assigned to build this. So I create AT underscore company code. AT underscore company code. So technical spec. So here we have tables. In the first column we have tables, and here we have what columns inside each table. So at the table, company code data is stored in what table? T001. In T001, what is the company code column name? BUKRS. The name of the company code is BUKRS. I mean the ID of the company code. Again in T001, name, description, name 1. Sorry, it is BUTXT. The name of the company code is BUTXT. Sales organization. Sales organization is in which table? TVKO. What is the name? What is the ID? I mean, technical name of the sales organization. What is the technical name? VKORG. What is the name? Now, where is this name stored? Name is stored in a different table, which is a text table. TVKOT. Under TVKOT, under which column does this description store? vText. Currency of the company code. Currency of the company code is stored in which table? TCURT. This is the currency table. So this currency ID and the description for currency is ltext. So currency ID of the currency is WAERS. So actually currency also has an ID. So that is in T001. That is WAERS. So for everything we have IDs and the descriptions. Company code ID, company code name, sales organization ID, sales organization name, currency ID and currency name. So ID and the name, ID and the name, and ID and the name. So now let us go to detail design documentation. Nothing but low level design document. So in here what we need to create, how many tables we have? 1, 2, 3 and 4. So what are these tables here? Table 1 is T001. T001. You have the second table TVKO, TVKO, TVKO. The third table is Third table you have TVKOT, TVKOT, TVKOT is the text table, and the last table is TCURT. So how many tables we have? We have 4 tables. Now how will each of these tables interconnect to each other? That is the next question. We know tables. Now what is the relationship between these tables? What are we creating here? We are creating a low-level design document for company code attribute. So in T001, what columns I require? I require BUKRS, BUTXT. In TVKO, what I require? VKORG. In TVKO, I require VKORG. In TVKOT, I require VTXT. In TCURT, I require LText, LTXT. And again, in T001, I require WAERS, WAERS. So company code ID, name, currency ID, name, sales organization ID, name. Now, the next question here is, now what is the relationship between company code and sales organization? One company code can have multiple sales organizations. So what does this mean? Okay, T001 company code ID, which is BUKRS. So now what is my requirement here? Company code should get sales organizations. So how do I get from what company code I have what sales organizations? So I need to join BUKRS of T001 to, you'll have a foreign key over here, which is BUKRS. So I'll join BUKRS of T001 with BUKRS of TVKO. So when I join, what happens? So what is this table T001? T001 is what table? Company code table. TVKO is what table? Sales organization table. Now, is any of these tables over here is a text table or an attribute table? Both these tables are attribute tables. Now, why we are calling them as attribute tables? Because this table T001 has different business entities that gives more details about company code. What is this company code? What currency it is operating in? Now, TVKO is another table which gives more details about sales organization business entities. So both these tables are attribute tables. None of them are text tables, first of all. So this is an attribute table for company code. This is an attribute table for sales organization. So I need to join two attribute tables on a condition BUKRS is equal to BUKRS. When BUKRS is equal to 1000, obviously in TVKO table you'll have 1000. So first of all, you cannot take text join because both of them are attribute tables. So on top of it, I need to get company code and sales organization. So I need to join both these columns equal to BUKRS of T001 equal to BUKRS of TVKO. So what is the join condition here? Inner join. Now why inner join? Both are attribute tables. My condition is BUKRS is equal to BUKRS of TVKO. Same company codes I need to get out. The company code is 1000 over here. Company code is 1000 over here. For this condition, get my sales organizations. So the company code is 1000. So what are sales organizations? Frankfurt, Berlin, and so on. If my sales organization is Frankfurt and Berlin, then you'll only have IDs again, because this is a sales organization ID. But to get text for the sales origin ID, again you need to join with the text table, which is TVKOT. When you join an attribute table to a text table, then what is the join over here? Text join. When you join a company code with that of a text table, so what do we require over here? This company code is in what currency? I'm sorry. This company code operates in what currency? For this currency, what is my currency text? If it is, for example, I would say MYR. Now what is MYR? MYR is nothing but Malaysian ringgits. GBP. What is GBP? British pounds. I get text from here. These are the IDs, company code name. The relation between company code and sales organization is we do a inner join. To get the descriptions, I do a text join. And finally, my requirement is achieved. So when do we have to use the inner join? First of all, both have to be attribute tables. In an attribute, you need to get common values between both these tables. Inner join is nothing but equi-join. It's simply a equi-join. So this is a business example. So today we only see the scenario. Tomorrow we'll see how to create this attribute view in tomorrow's session. Any questions for today's session? Please let me know. Thank you. Thank you everyone for attending today's session. We'll see you tomorrow. Any questions, please type in your questions. So here we have one question here. Whenever we have foreign keys, can we use an inner join? It depends on business example. Like what is the condition you want to take? Foreign key is only a key that enables the join condition. So we need to have at least one common key when you want to create a join condition. Next question. Can we able to create a new calendar? Yes. Especially on the ECC side, on the source system side, you can upload your own calendar types. So these calendar types can be replicated into HANA using data provisioning method. And then you can combine these calendar types when creating analytic views or calculation views. Or you can join or combine based on the condition, but still you can maintain your own calendar types in the ECC. And these calendar types you can replicate and then create views analytic or a calculation view. So next question, I mean a foreign key for organization values like BUKRS, WAERS, VKWRG. For these, can I use inner? Yes, you can use. Yes, exactly. Next question, can you can this can you can you again tell us about derived attribute view? Okay, derived attribute views are basically used. So, for example, if you see here, I have different business entities over here, like AT customer, AT bill to party. I have different business examples like AT bill to party, AT customer, AT ship to party. Now, either you can do two things. Either you can copy an existing attribute view when you want to have different join conditions, or either you can reference to an existing attribute view. So when you reference, what are we trying to do? We're trying to reference the same attribute view again. This is not a different attribute view at all. It is the same attribute view you're trying to reference. The reference itself says that we're actually referencing to the same attribute view. But what is the limitation of an analytic view? I'll tell you one example. I'll tell you the limitation of an analytic view. The limitation of an analytic view is we cannot take the same attribute view again when doing multi-dimensional analysis. Like for example, if you take an AT customer, we cannot take AT customer again with a different join condition when analyzing transaction data. For example, one you have taken as a referential join and the other one you have taken as a left outer join. One condition you have applied referential join and the other condition you applied as a left outer join. But the view is same. AT customer is same. But AT customer, I want to apply two conditions. One with one join, another with other join. But what is the issue here? I cannot take the same attribute view twice. So what I can do, I can create a derived attribute view now. Nothing but an alias. So once I take alias, I can use or reuse the same attribute view with a different name based on the join condition. So next question, does BU text not make T001 a text table? Yep. BU text, you see, it is a description. The description is not stored in, a different text because T001 is an attribute table. So why I call it as an attribute table is because I'll log into the ECC. Provide the username and password. Continue with this logon. SE11, T001. You see here, BU KRS, BU text, city of the company code, chart of accounts, address of the company code. So basically this is nothing but an attribute table. It gives more details about the company code. So it doesn't have, we're not storing the company code text in different languages. So only one company code. We're not maintaining these descriptions in different languages. We're only maintaining English. And that too, for this company code, it is maintaining a lot of other details. So this is nothing but an attribute table, not a text table. No question here. Do data provisioning and HANA replication mean same? Do data provisioning and HANA replication mean same? Yeah, it is same, but replication is something we mainly specifically use in real time. Means replicate. Whenever you make any changes, immediately it's available in target. So in data provisioning, there are different ways we can replicate data. Like for example, for using ETL, extract, transform and load. To extract and to transform and load, we use BODS. BODS is one of the tool in the data provisioning. So under data provisioning, provision means movement of data. When you want to move data, we have different set of tools. Like SLT, it's basically called as trigger-based replication. Trigger-based replication mechanism. It is based on database triggers. So based on database triggers, it will identify change in the source system and that change will be replicated to target, SLT. BODS is an ETL tool to extract, transform and load to target. So under data provisioning, we have different tools available. Each tool is used for a specific purpose. SLT used for real time. A totally different use case. Whenever you require a real time, as and when you insert, update, delete on a table, immediately it should be available in reporting. Immediately, within a blink of an eye, real time. BODS, not optimized for real time, batch process. Complex transformation, you want to merge, you want to transform, you want to do data cleansing, you want to consolidate data, you want to write different business logic. All this can be achieved using BODS. So each tool has a purpose, and all these tools together comes under data provisioning. Thank you everyone to attend today's second once again. I'll see you tomorrow same time. And I encourage to read materials HA100 and HA300. These are the introduction books. Please, as and when you have time, please read. And tomorrow I'm going to upload our first assignment. You can have a look at the assignment. You can complete and you can email back. I can just track your assignments. Thank you so much. See you tomorrow same time and have a great day ahead. Thank you.